Hello. Are we ready? Okay. Yeah, good evening. I want to talk about graph data and exploring it with Neo4J and Spring Boot. And yeah, I'm Daniel. I'm for 12 years in Vienna now, and I'm active in the open source community. And I joined the Java-Vienna group in 2014, thanks to Dominic. And yeah, this is the journey we want to take this evening. First, I want to say why modeling data as a graph is a good idea, and why I hope I can convince you that it is a good idea to do this. I want to introduce you the Neo4j database and its Cypher query language, which is different from SQL, but there's a reason for that, I think. And then I will explore the data model from the Spring Pet Clinic. This is a well-known example. I guess everybody knows it from. And then we want to port that model to the graph database and integrate everything into Spring Boot. So that you, when you leave after the talk, you have a good idea how you can use a graph database in your day-to-day work. Okay. And if you have questions, please ask them. I don't know how familiar you are with the topic. Okay, so first thing, why we want to do this? I guess all of you are familiar with a picture like this. I guess you have things like this in the office. Or, maybe you also have seen drawings like that. Have you? Yeah. Yes. Okay. And maybe you also have seen something like that in your company. There's a lot of hardware and that has to be managed, and there are relations to all these things. And this is what's all about. I mean, we have a lot of things or people that are connected in different ways, and we want to model that. We want to work with the relations, and this is the important part of graph database, because we can draw the stuff all the time, and we are drawing that stuff all the time, but we cannot model it the way we would draw these things. And even that, of course, we have a lot of diagrams, but okay, this is a simple example. We have a Joe, and the Joe has a lot of friends, and what we can see here in this example is that some of the friends of Joe are connected. There are connections between the friends of Joe, but some are not connected. And we also have different kinds of connections, because Joe is a friend of John, but he's also a colleague of John, which is a different thing. And we can express this difference in a graph just by using that annotations. Any questions so far? Okay. But this is a very simple example. I mean, we have also real-world examples. Facebook is calling it the social graph. Maybe you've heard of that. And Twitter and all social media have that model behind their services. We also using graphs for routing problems. If we want to travel with the car, we also have a graph. The roads are a graph. And it is also used for recommendation engines. You know that from Amazon. You bought something and then say, well, people that bought the product you bought also bought 2 other products. And these kind of problems you can also quite easily solve with a graph. And the last two are some problems they really solved with the Neo4J database. It was analyzing the Panama paper leaks, where people did money laundering, and there were papers leaked about the money laundering, and they were analyzing it using a graph database to figure out the proxy accounts for the people. And another example is, and I also have linked the articles describing that, so you can read it if you are interested in that. The second is the story behind Russian Twitter trolls, where they could prove that one message had only one source in the Twitter network and was published over 100,000 accounts or something like that, so that it, to the usual Twitter user, it looks like a natural message that was sent on Twitter, but it was not the case. And there's also an article describing that. And what are the basics that we need? I mean, the computer science is defining a graph as a set of vertices and edges. And what we want to use is a very special graph, and that is called a directed property graph. And that means we have properties on the nodes of a graph, and we also have properties on the relations. And I will show you how this will look like later. And we are not, in the Neo4J speak, we are not saying vertices and edges, we say nodes and relations, because this is the thinking behind the data modeling we are doing. And there's also another special thing. We can put labels on nodes, and we can put more than one label on nodes to specify to identify special kind of nodes. And I will also give you examples for that. Neo4J, it was built in 2007. Today I read it was even built earlier, but this was the first version. They started with a MySQL backend. This was written in one of the books at least. And the graph model was kind of front-end to that. But that didn't work out quite good, so they started to re-implement the backend that it is fitting the graph model better. And one of the key features is the so-called index-free adjacency. That means that the costs of traveling from one node to another are equal and are not depending on the position of the index where the node is stored. Is that? Yeah, okay. And Neo4J is also asset compliant. There are other NoSQL databases, they are not, but for the graph database, we also have transactions and stuff. Okay. There are two editions of Neo4J. The community edition, it's a GPL version 3 license, and for the enterprise edition, they have a lot of commercial licensing, and it's also a GPL, but you cannot figure out that by visiting the website. But if you look on GitHub, you see that's also a GPL. But maybe if you want to benefit from the enterprise features like clustering and load balancing and stuff like that, you maybe want to have a commercial license anyway, so this shouldn't be a big issue. And the community edition has some limits, but I haven't figured out what the limits exactly are. It should be good enough to start with. Yeah, for installing we have packages for various platforms, Windows, Linux, Mac. And of course we also have Docker images for now, so this is easy to deploy it on various cloud platforms. There are also cloud templates available for Amazon Cloud or for Microsoft Cloud. So there are a lot of opportunities. You can also try it out online without installing it. There are the Neo4J sandboxes where you can log in via Google, Facebook, or Twitter or something, and then you can fire up a sandbox, and it's active for 48 hours or something like that. And then you can play around with your own graph models, or you can use some sandboxes, they already have graph data in it. For example, the Russian Twitter troll data, there's a ready-to-go sandbox. You can play around with that. There's also a sandbox featuring the Trump administration, so you can see everybody who's connected to the current US president, if you're interested in something like that. And was that a question? No. Okay. There's GrapheneDB. This is a company that is a kind of a front end to Amazon Cloud. They pre-package containers containing Neo4j, and there's also a free plan you can subscribe to. There you have 1,000 nodes and 10K relationships. So if you don't want to install it, maybe you should start there. Okay. The best way to access and to work with graph data is Cypher. It's a query language that is like the SQL is for relational databases. They invented that language for the graph, and it's developed for Neo4j, but they opened it up in the Open Cypher project to support other databases, and currently the Apache Spark project is implementing open ciphers that you can also use Cypher queries for Apache Spark, for example. And I hope that more databases will follow. The language is optimized to be human readable, and it looks a bit like ASCII. And it's because they said database queries are more often read than they are written. So you have, it's a common use case that you have to read existing queries and try to understand what they are doing, and that's why they are optimized for that. Okay, so how this looks like. The notation is something like that. You have nodes, they are the usual brackets. Relations are in the, how they are called? The other brackets. And yeah, I have to apologize, I'm a non-native speaker, so yeah, okay. And you can write something like that would match a node that is related to another node. This is a label with the colon. Yeah, so, and this is the way how you can read that. So first, we of course we have to add some data. So we have to create statements, and we can create nodes and relations with it. And we have merge that works the same way, but it's only creating new stuff if it's not there already. Okay. So if we remember the picture I had before, we created Joe and we put the label person on him. This is a label. We can interpret this as a type, but yeah, it's more than that. But it's easy to think of it as a type. And it has attributes. The first name is Joe, and it's some age. And we do the same with John. And this Joe here is a variable. I could call it X or something like that. And a variable is active during a transaction. So if I'm using these 4 statements in one transaction, I can exit that variable. So this is what I'm doing here. I'm creating a friend-of relation between Joe and John because I have the variables defined already. Is that okay? And I'm doing the same for the colleague of relation. And if we want to get out the queries, the slides will be online. So if you, because I saw you taking photos anyway. The queries are following this pattern. We have the match statements because we need a start point where we explore the graph data. We need a point to start with. Then we can filter this with the where statement, but it's optional. And then we define what we want to see from the result set. So you can think of it, the return statement is in some way equivalent to the select clause in the SQL language, but I'm doing it the other way around. In SQL I say select this and this and this from some stuff, and here I'm doing it the other way around. I'm matching the data, I'm filtering the data, preparing all the data, and after that I'm picking what I want to see from that. So this could look like that. I mean, this statement is longer than it has to be, but I think for the first time it's okay. We say match all nodes with the person label, assign it to the Joe variable, and when the first name is Joe, then there's a match. And then we return the node as is. And the second one, what we do is matching Joe again. And what we also can do is we can use the results of that query as an input for the next query, and with that with clause. So I was matching Joe, and with Joe, I could now match the friends of Joe into that variable. And after that, I'm returning both of them. Yep. But if I have 2 users for Joe, then I'm sorry, I didn't hear that. 2 users named Joe, will it still work, or will it be somehow strange? No. If you have 2 users with which matching query. Yeah, I would get 2 users. Okay. Yep. This is just a pattern. I mean, if I really want to have unique stuff, I need to match them on a unique something, perhaps an ID or something like that. Okay. The nice thing, I mean, if we go back one slide, what we see is this arrow, and the arrow is the direction of the connection. There could also be a connection in the other way around, and so the arrow would point in a different direction. But what I also can do, because this is a graph, I can just ignore that direction and matching John first and leaving out that arrow. And this means I don't care about the direction of the connection, and I just want to match everything that is connected with a friend of type of relation and getting the result. Was that okay? Okay. This is just the same query we did before, but this is the way we would write it in a real-world scenario, because we can say we match John as a person and put that attribute just right into it, and yeah, don't care about the rest. There's a good book to start learning Cypher, and that's the way I did, because this O'Reilly book is available for free on the Neo4J website. The only thing you have to do is to register with your email address and stuff, and then you can have that for free. It's written for an older version of Neo4J, but that doesn't matter that much, because I really like the style of the book, and I also like the introduction into the Cypher query language, and it's not too outdated, so that you can catch up with newer versions. Yeah, of course, there's also a lot of stuff on the Neo4J website, especially the reference card, where you have all the main clauses written on it and how to use them. I also read this book. This is quite nice because it's more focusing on the version 3 of Neo4J, which is the current. And there are also a lot of YouTube presentations with a lot of people that are using Neo4J in production and for real-world scenarios. And this is quite interesting. Yeah. Who knows the pet clinics example from Spring? Okay, most of you. Okay. It's not a very complicated one, so if you don't know it, it's not a problem. Yeah, it's a well-known example, and it uses, of course, a relational database. I mean, it's a funny thing that relational databases are called relational, but they're actually quite bad at handling relations. But that's another thing. I asked a friendly program to draw me the model of the pet clinic. If you have a first glance at it, do you detect any flaws when you look at this? Is there anything that looks weird to you? Yeah? There's no connection between visits and vets? Yes, thank you. That's what my first thought was. There's no connection. We have the veterinarians as an island here, which looks a bit weird to me. But well, that's okay. Then I wrote a secret query but we start with the island. This is the secret query we need to get all the surgeons. And we see we have 3 tables involved, and we have 2 join conditions and a filter condition. And what we get is this result. And what we now want to do is to add the surgeons and all the vets to the database. So we use, where's my mouse going? Ah, yeah, okay, I see it. First we create Linda, and all these things separated by a colon now are labels. So Linda is a vet, and she's also a surgeon, and she's also a dentist. So we just put all these labels on her. Then of course her name, and the Raphael is also a surgeon. The thing is, I want to also give everybody this label because they think of it that they are a query criteria. So you can list. You want to have a list of all the vets. You want to have a list of all the radiologists, stuff like that. So, or think of types, yeah, types of persons. So, and if we now want to do the same query with Cypher, to have a list of all the surgeons, okay, we just do this. This says match all nodes that have the label surgeon on it, and that's it. We don't need join tables and other technical stuff to get there, but just getting a list of nodes with that label. Okay. For the port to the Spring Boot application, I made some small changes to the model because first I renamed owners to person because it feels more natural to call them persons, and to put the fact that they own a pet into the relation. I also thought about adding the label person to the vets as well, but I left it out because I did not want to rewrite the front-end code. And what I also did, I pulled out the cities as extra node. They are in the owner table in the original model. In a richer relational model, you would pull them out as well, the address data usually. And I will tell you why I did that. And what I also did on the model, what I haven't put to the front end was I added a medicated on relation between the vets and the visits to fix that flaw in the model. Okay. Yeah. One motivation to work with graph databases is to get new insights into your data. So, I mean, the relational model of the pet clinics works well with that application. It's not a big deal. I mean, I'm now using another database, but think of it. If you're the owner of the pet clinic, and a salesman is calling you that let's say they invented a new dog food, and they want to start a marketing campaign, and they're asking you, where are the dogs living? I mean, they are the targets of the campaign. I mean, in fact, the owners are the target, but that's another story. But can you tell me, you are serving, your clients are from different towns, in which town the most dogs live, so that we can start a campaign there. And we can do that. And with that query, and what we are asking Neo4J for is matching all nodes that have the city label on it, and they should be connected to nodes that have the dog label on it. And the mental model, if you think of it, you start from a city and you know that there's a connection between the city and the owner, the person. The person lives in a city, and the person owns a dog. So but I do not care at the moment that they live in the city and that they own the dog. I just want to travel the connections. And what I also do here is I want to limit the depth of that connections to 2, because there could be circles in a graph. Yeah? You maybe everyone has experienced that, and you have to be careful that you do not match your whole graph by accident if you are matching too much. But with these 2, you say only to the depth of 2, and then I'm finished. And then I'm returning the city, and I'm at the count of. This is very familiar. This is the same stuff you have in SQL as well. And then I'm also ordering it. And if you want to, I can show you that in the database. So this is better to. Yeah. Yeah. Yeah.
In case there are 2 ways to reach from city to dots, one via person and one, I don't know, with another connection. Would it be the same query or?
No, they are not temporary. I mean, in your graph you have a connection. I mean, maybe I can show you that in the Neo4J browser. Maybe that's better. Please wait a moment. Okay. So we're having a short break, and after that I will show you the model and the graphics to it to understand what the queries are doing and how to integrate it into Spring Boot. Okay. Ready? Okay. This is the Neo4J browser. This is the UI that is shipped with Neo4J. And I did a simple query matching all the cities because I wanted to answer the question that we had before the pizza. And I'm getting this. This is a set of cities, and I can now expand these. And this is some data I inserted into the database. And the resolution is too bad for that. Maybe I can pull that up. Yeah, I can. And this is a dog we have. And but I also can see the result as a table, as you would as a JSON, or so this is something you would also get from other databases. But it's nice to have the graph away. And if we have a look back at that, what we can see here, I mean, I matched the city, and this is mean. And I have this relation, and I have this relation, and this is a pet. And in that case, it's even a dog. But I can see the path I have to travel to get the result. Is this answering your question? I don't know who asked before we. Anyway, so if I'm doing this query that I had on the slide, in the graph it's not that much to see, but if I switch to that view, I can see I'm getting all the cities and the count of the dogs. So maybe it would be a good idea to start in Madison with the campaign and not in Vienna. So, or in any other city where no dog lives. So, okay. Oh, nice. Okay. Yeah. The pizza came at the right time, so we are at the last part of the talk. One of the spring inventor, I forgot the name, is also on the board of Neo4J, so the integration is very good. What we need is it's called the Neo4j OGM. It's like an ORM, and Spring Data is working on top of it. So for some of the code you will see no difference to any other database. And of course there is also a Spring Boot starter for Neo4j. So this is how it looks in the POM file. Nothing unusual there. And this is the configuration. It looks very much the same like on Dominic's slides. Apart from that, it's enable Neo4j repositories. And I can put more than one package to that. So if I want to store my models for the graph in different packages, I can add some more packages there as well. And here I can get the session factory. But and what I'm doing here is loading the database configuration from my properties files. If I'm only using the OGM, okay. I would use the session to store and load the data. In Neo4j, this is done in Spring Boot. This is done via the repositories. Okay. How does the OGM works? We have two types of entities. We have node entities and relationship entities. we only need the relationship entities if the relations have properties. Otherwise, we just use annotations in the node entities. Is this a question now? Okay. The pet clinic example is only using node entities, but I will give you an example for a relationship entity as well. I used the base entity class from the pet clinic and reworked it as a base class for the node entities. What it is doing, it is managing this auto-generated ID. This is an internal value that Neo4J is using for storing the nodes and the relations. You should not rely on these IDs. It is something like the position on the index, and it is something you should really not touch. If you want to have some IDs that you are using in the database, you should put some UUID properties or stuff like that. And what it also is doing is the name of the class will be added as a label to the node. So, but as we can see here, the base entity has no annotation in it, so it is not a node for itself. This is the node entity for the vet, and what we can do here is, with the labels annotation, we can have access to the additional labels that are on the node, and we will use that. And I can also annotate the properties with the name that are in the graph. The pet clinic frontend is insisting on camel case variables, but I do not like to have camel case variables in my graph, so I annotated the name otherwise. If the name of the property is matching the name of the variable, I can leave out the property annotation. And what I am doing here is for the specialties of the vets, surgeon, dentist and stuff, I'm returning them as a join of the additional labels. Because there's only one view in the pet clinic that's showing you a list of the vets and their specialties. There is no logic in it, there's no querying, no additional stuff. And so I did it that way. As I said, I pulled out the city property to be in a different node. So this is how I can define relations. I'm giving them a name, and in that case, I can have more than one pet, so this should be a set or a list. And what is also important, you really should do this initializing. It's a very bad thing if this can be null, because the mapper has done a problem. So it should always be allocated. And this is a very special kind of relationship. This is a one-to-one relation. And I discovered a bug in the OGM, or at least I believe it's a bug, because at the moment it is, if you are setting a new city to the person, a new relation is created, but the old one is not deleted, which I think is a bug, but I haven't gotten any response to the ticket I created, so maybe they will fix it up. I will have to talk again on Linux Wochen in about 2 weeks, 2 or 3 weeks. And maybe it is fixed until then. And what I also can do is I can define the direction of the relation. And So I have a person owning a pet, and the pet has an owner. This is the other direction. So it is the type of incoming. And what is also was important to add that JSON ignore annotation on it, because if you don't do it, the Jackson mapper runs into a loop and running out of memory because the person owns a pet and the pet has an owner, and this is a cyclic thing. But this is currently only used in tests, so anyway. And I have defined the was on relation for the visits. Yeah, this is an example from the documentation, the Neo4J documentation, also the OGM documentation. They are using a movie database with a lot of movies and actors that played in that movies. And what we can see here, we also have that generated ID, like we had it in the nodes. And we have to define a start node and an end node, because there are no dangling pointers allowed in the graph. It's also, if you want to delete a node and there's still a relation attached to it, you are not allowed to delete the node. You can say detach delete, then the relation is also removed. And we have the property title, so I guess this is the name of the role the actor had in the movie. And as I said before, if you do not have any properties, the entity is completely ignored. Okay. Yeah, this is something you should be familiar if you're using Spring Data already, and it also the full Spring magic is kicking in here. So this is an interface, and I write that method as a find by name, and the magic is creating a database query that is matching the entity by the property called name. This works the same way like it works on relational databases. The only difference is that Neo4J insists that this ID type has to be long instead of int. And what I also can do, this is also like with the relational databases, I can annotate the function with a query, and I can use a cipher query for that. What I'm doing here is matching all labels, or I want to get all labels that are on nodes that have the pet label. This is a bit, it was a bit annoying part, because I'm getting a list of collections out of that, because I have 10 nodes or something like that, and each node has labels. And so it's a list of lists, which is not so cool. And what I then did, and maybe I should in later versions I should do it in another way. But what I did here is I'm walking through the collections and filtering out the duplicates, so that I really get only a list of subtypes of pet. Is that understandable what this is doing? Okay. Okay. Yeah. To prove that I really wrote some code, I can start up the application. So we can try it out if you like, or Okay, I'm sorry. uh, I said we can just do some clicks to the applications if you like, or if it is too boring to you, we can just skip that. It's up to you. Okay, no protests, so I'm clicking. It's a really crappy interface if you ask me, but I haven't wrote it. It's just the crappy mouse. There is a link to the source code so that you can explore it for yourself. And I also included all the cipher queries to create the data set, so you don't have to worry about that. It's also, yeah. Okay. Okay? There's more. Under the acronym of APOC, it was called a package of components, and now it's called awesome procedures and ciphers. These are ready to go implementations of graph algorithms that are available that you can call from cipher queries. You just have to enable them on your Neo4J database. It's a package, just click and I want to add it. And there are, for example, PageRank, Dijkstra, A-star, and stuff like that, and a lot of other goodies that you might need to travel through graph data. So you do not have to reinvent the wheel. And there's also, I mean, who of you knows GraphQL? Okay, it's a query language invented by Facebook for their social graph, and it's a language to develop your API a bit better. And it is supported by Neo4j. You just have to say, I want to have support for GraphQL, and that's all you have to do for that. And you can combine it with REST calls if you like. Yeah, I already got the question today, how to convince the managers. First of all, you can import data from existing data sources into Neo4j. So you do not have to start from scratch. You can import CSV data or any GDBC accessible data source. And you also can define some mappings for that. There's a lot of documentation on how you can do that. They're also developing new tools to support you with that. So that thing can give you hints how which attributes maybe should be better put into nodes instead as properties of the same node. And after you imported the data, you can try to adapt the model to your questions. I mean, they are saying you should always model, or you can test if you did the modeling right, if you're getting the right answers to your questions you have to that data. And if that is working out for you, then you probably did it right. Okay? So there maybe sometimes it's better to have some properties on the node or to put it on the relation. It really depends on what kind of stuff you're interested in. As I showed you, you can integrate it into a Spring Boot application. So if you already have Spring Boot applications, you do not have to learn very new stuff apart from the OGM, but it's not that difficult. So you do not have to learn new languages. You do not have to change the way of programming. But if you are not into Spring or Spring Boot, you can also use the OGM without Spring. It's no problem. And yeah, I think this is also important. There is commercial support available because managers like it to have it on the list. So, and yeah, because of this approach, if you're not starting from scratch, but playing around with existing data and see if you can get new stuff out of it, you do not lose anything. You do not destroy everything. I do not say throw away all your stuff you have, but you can play, you can experiment, and if you think, yeah, maybe we should switch, then you can do it. But you can always gain new insights, and maybe you discover stuff that is hidden in your data you haven't thought about. Without hiring a data warehouse specialist, it costs a lot of money. Yeah, there are some links. I guess we will put a link to the slides on the Meetup page afterwards. And there's the link to the Spring Pet Clinic. I cloned the AngularJS version because I was not interested in the front-end part. So don't blame me. You can also use the Angular 5 one if that suits your needs better. And there's also the link to the slides there. The sources to the slides, if that's interesting for you, I don't know. But we are open source, so I don't hide it. And I also found this interesting article. This is maybe interesting because it tells you how to get from an existing relational database system to a graph database, step by step. Yeah, so thank you, and you can ask questions if you like. Yeah, you can add properties to a relation, as you can say, you can give it a start date, an end date, or whatever. Entschuldigung?
The first version is on liquid base, old Neo4J. Can I database version is in liquid base?
The Neo4J version I used, I used 3.3.4. But yesterday there was a 3.3.5 release.
Can you actually version it using
Liquid base. You can use a schema and you also can enforce it, but you don't have it. No, I don't think it works with liquid. I don't know anything about that. The distance between the... You can count you can count the relations over. You can also use other aggregate functions on all of this stuff. Okay.